You're having a conversation at lunch, and there's some of these guys in the service subcontractor business, and they're given a part to do something with. They have to test it and get back to their customer with it, and there isn't the technology that exists completely for them to be able to do that. So they'll have to make the circuit board over here, and they'll have to get a connector for it over here, and they'll have to buy a burn-in oven over here, and then the backplane for it, and put all of that together. Now, is that person considered an intertechnologist? Some of us, that's what it is that in the world of the burn-in, that's what has to happen a lot of time, is that, you know, by the time it gets to that person that has to do that last little bit of checking on it, you got to throw an awful lot of it together, and it's a lot more inclusive than just in the packaging aspect of taking a chip and saying, well, now I'm an interconnectologist. Just trying to bring more people to your party.
Absolutely.
Yeah.
I think that nobody would argue with that. Any comments?
100% agree. It's open to whatever you want to make it into.
One of the things coming from the front end that surprised me was, I thought a package was a package. You know, once you said a BGA, it was a certain package that had very clear definitions and so on. Then I found out that there were many, many kinds of BGAs. Every customer had their own brands that they liked or own flavors. I think if we can use interconnectology and kind of drive roadmaps, some sort of mind melding, if you will, on what this needs to be, it just helps the whole packaging and the back end, the interconnect part of the space, become much more efficient and, you know, deliver solutions much faster, which translates into cost savings, optimization, so on and so forth.
Really, when you start thinking about 3D interconnect in particular, where, you know, maybe you have a logic device and you want to stack multiple memory devices on top of that and access the memory only through the logic device, how do you test that? And that's really, you know, testing 3D integrated products is really a big challenge that the industry is trying to deal with. I absolutely think that's part of the art and science of developing a integrated semiconductor solution. So yes, that's part of interconnectology, and that's really an important part because as we disintegrate ICs into functional blocks that are maybe optimized in different fab nodes and put them together different ways, 2.5D, 3D, other ways, how do you access everything you need to access and make sure the whole thing's going to work when it ships to the customer?
Well, I think I'm going to throw out is who's going to invest and develop that technology, because you got some people are really good at processors, some people are really good at memory. So is it going to be one of the big players, or is there going to be like a third party comes in and says, well, I'll take your memory, I'll take your processor, I'll take your flash, your transmitter? Is there going to be a third party that's going to be driving the development of this, or do you think it's going to be one of the key players given the consolidation stuff we talked about this morning?
I think at least for 2.5D and 3D, all the big players are in. You know, you have TSMC publicly out there, of course. But then I would argue that a lot of the big IC manufacturers are also playing in this particular space.
I think when you get to silicon that comes from multiple suppliers, you know, take the obvious example of logic plus memory, I think there's one company in the world right now that can do that, and it's Samsung.
But I think that the real shift in thinking about interconnectology across the whole product is somebody like Johnny Ives, the chief designer at Apple, will want to do X, and it will flow down from X. In the old days, you only had a choice of buying a microprocessor from Intel or AMD. It looked like this, it had this many pins. But in the new world, they'll say, this is what we need. And so you packaging guys or your interconnectologists, you're going to have to put these 6 dies in here. It's going to have to be this size, and it's going to only consume this much power to make the end product work. And I think that's the real shift.
People ask me a lot when I think 3D technology will be widely deployed, and I say I know exactly when it's going to be widely deployed. I'm the only person in the world I know exactly when it's going to be widely. It's going to be widely deployed when the next level of user experience that the end user of a hand phone expects can't be achieved with existing technology.
I used to live in Japan, and I used to be jealous of what they had. They have a word for interconnectology, and too bad I was not smart enough otherwise to come up with it. So they have a word they call JISO, J-I-S-S-O. JISO has many levels below it, And it has advanced packaging, and it has testing. And I used to be jealous that we did not have an English word for it. And so now, thank you for it.
Right here, Nick Langston, R&D Circuits. Interconnectology, I think it's a perfect word. Everybody in this room practices interconnectology. We're bringing different disciplines, mechanical, thermal, electrical, and you have to be able to quantify the value of that advantage to your customer without hard data to tell them why you're charging them more. The point being that it's difficult to make those advances when we're not part of that feedback loop that our customers are typically, where they'll see the results on the test floor and they'll be able to quantify it immediately. It's really hard to stay in that loop and get that data back to know what your next step is in advancing the interconnectology.
It's always difficult when you're not a consumer product company and you don't have real-time feedback on what the consumer likes and doesn't like about your product, and sometimes you have to manage up the supply chain. So if you're, I've got many years in the OSAT industry, understand what you're talking about. We don't always know what a Samsung Mobile or an Nokia or an Apple really wants 2 years from now. But the challenge is to find out, is to put some effort into managing up in the supply chain.
Oh, Larry Furman from Plastronics. In the last 15, 20 years, the most successful relationships that I've had introducing sockets, it's when we had a strong correlation to the packaging engineer. Having the panel in this room begins to show the interrelationship between advanced packaging and back-end test. There is a natural flow that we've seen the panel address where it's either the consumer or the designer at Apple or someone else pushing down their ideas. But until we really get advanced packaging to communicate in advance with back-end, giving us enough time to develop the infrastructure, really the idea is introduced, but the fruition of that idea gets held up at the very end until we can figure out how to test or provide infrastructure for you to test all your great ideas. When we finally get to the point where we're looking at back-end tests, back-end infrastructure up front, that's when you're going to start to cut the lead times and the deliverables to the end user.
Just when you were describing that, I would say 10 years ago that the front-end people never told us anything, right? And that went on, and there was so much design margin that it didn't matter, right? So, typically the node would keep changing, and we might see a different pad stack for wire bonding, but it could be dealt with when the first silicon came out. And then 130 nanometer copper low-K dielectric came out. And I remember being at Amcor, and the wafers all started coming out of TSMC, and none of them passed rail, not one. So it shut down the industry. And because that lack of communication had existed, and because there'd been so much design margin for so long, nobody cared about it. And it finally hit the wall, and products got delayed 3, 6, 9 months. And I tell you what, all the major OSATs are in the fabs now. They all have upstream relationships with the foundries and with the leading, and the IDMs, obviously have that more integrated service. In fact, you look at most of the fabless guys, they now run packaging and fab process engineering under the same organization. So I'm not suggesting that you need a big blow up, but yeah, it helps.
At the wafer test level, there is a lot of activity looking at all the issues created with 2.5D, 3D, and there are a lot of challenges there. What I haven't seen, though, is enough of the big players worrying about it at the package level. I think some people are just burying their head in the sand, say it's a package, and you test it like all your other packages. And I think that's a problem, but I think history will probably repeat itself, and it won't be as simple as just designing a new socket with a different pin out. There will be issues when you take those advanced interconnect structures of 2.5D and 3D and try to test it like any other package.
With bringing 3D integration, 3D ICs to market, there's a lot of lessons that have been learned. A lot of this talking and co-design and co-development and breaking down walls and collaborating has really come out of bringing that to market. And I think hopefully with the next generation technology, whether it's silicon photonics, whatever's going to be next, that the whole supply chain from chip all the way through test talks about it at the same time, and maybe things can happen a lot more seamlessly, and it won't take as long. So I want to thank everybody for coming today. I think we had a wonderful panel. I hope you enjoyed it.